And Andy Postle, the floor is yours, as they say.
Thank you. So I've got no idea who I'm talking to or how many people I'm talking to, but
Got 20, you've got 23 or 24 in the room.
Okay, and everybody's sort of in the survey game.
They certainly are.
Great. So well, I'll start with a very unabashed sort of little bit of promotion for Allspars and tell you who we are and what we are, and then hopefully that will then lead into all the other things. Quite happy for this to go off piste at any stage in the game. Obviously, all these things are very much geared around sort of experiences that you guys have had or might have, or questions that you've got. So at any point, please happily direct those questions at me, and I'll do my best to try and answer those and give you advice without this taking much more than an hour, because I know you've got other people behind me. So we'll start with who are Allspars. So Allspars started back in 1997. I was the sort of founder and back then, and I've been in the rigging game for about 13 years before that. So been at it quite a long time. Probably really before there was even a proper rigging industry as we know it today. Back then there was Harry Spencer, Peter Morton in Poole, and Peter Lucas in Dartmouth were kind of the three main riggers back in the mid 80s when I was messing around with this when I first started. It's changed quite a lot in those intervening years. Our business, our core business, is 30 to 60 foot cruising boats, although we pride ourselves on the fact that we look after the little nippers with their mirrors and oppies at one end of the scale, and we will look after boats up to about 100 feet, normally with owners that have progressed up through and they've been clients of ours all the way through. We don't normally like doing super yachts because you spend more time talking to lawyers and project managers than you do owners. So we started in 97 here in Plymouth at Queen Anne's Battery, and have evolved and grown here. We then started our second office, which is at the Premier Marina in Swanwick, back in 2014. And that's just grown and grown and grown. And then more recently, we started a new Falmouth operation, which has just moved its home to the quay right in the middle of Falmouth Harbour. So we're waterside. All three facilities are full workshops with all the plant and equipment and machinery and stock required. So we are a team of 25 people now across the group, and we have within that sort of a lot of riggers within that team, and we travel wherever and sort of internationally to do our work, not just UK based. In our growing pains of trying to get subcontractors to make things for us, we eventually started our own machine shop and fabrication shop, and full hydraulics workshops here in because we just couldn't get stuff made fast enough in our time frames and to the quality that we wanted necessarily all the time. So we take control of those things a little bit more easily by doing it in-house. Unlike almost all other riggers, we are also a fabrication shop for masts as well. So we still make a lot of customizable masts. So we will start with bare tubes, cut, shut, taper, fabricate welded head boxes, and make a completely custom mast. Not many people can do that anymore. We do, as well as rod rigging and composite rigging. It's all made in-house here. We've got machine rod presses here in Plymouth and also in Swanwick. So we can do up to -150, which, put into concept, is a solid rod about inch in diameter. Big hydraulic presses, and we'll talk about that in a minute. We carry phenomenal amounts of stock, and that's kind of what sort of links Nick, who heads up our TMS division. So TMS is Technical Marine Supplies. It's a trade-only distribution company that sells parts, and Nick looks after all of that with his team. And it's kind of grew out of Allspars carrying so much stock in order to be able to fix things quickly and in a timely fashion, rather than having to wait for parts to come in from different manufacturers all over the world. We also do a lot of architectural stuff, as you might expect. It's not just wire, but also bar stock and threaded tie rods and bits and pieces. And as a company, we sort of invest back in. So we do quite a lot of sponsorship stuff with some big dinghy events, and we help quite a lot of upcoming youth sailors. I'm not a great supporter of people who buy projects and decide that somebody else is going to fund their grand plan to cruise off around the UK. If you're old enough to buy the boat, and then you should run out and afford it yourself. But youngsters, we have always supported and nurtured as we go through. So that's little history. We'll move on. What you guys would like to try and do, I believe, is understand how we make rigging. So we're going to quickly cover that, and then what causes the failures of these things like down the line. So hopefully you can see a screen there now that shows a little wire Technic machine.
You can.
Which is what we call a rotary swage machine. So it's got a little hydraulic press that pulls the swage through very specific dies that make everything to very specific tolerances. So the middle picture you can see there is a swage eye set up in the dies. The wire is pushed into the swage. Black magic marker sort of marks how far the wire has gone in. You pull the wire back out, and you also put a mark on the outside of the swage to make sure you set the dies at exactly the right location to start pulling it through. The black mark is there on the wire, very specifically where the pen's marked there, because you need to make sure the wire doesn't move in the swage process, so that you have got full depth of wire right in the swage. If a black mark is still visible once you've made the swage, it wasn't right in home all the way, so it then becomes a reject, and we would never use it. When you're doing the swage, it only needs to be rolled once. It does not need to be rolled twice, and certainly should never be turned through 90 degrees and rolled again, because what that actually does is open up the first roll. With some wires, especially what you guys might know as Dieform, which as a brand is no longer available, hasn't been available for probably about 15 years. But those extra strong high load wires, we use a Hammer Pro. It's a really, really dense product, so it doesn't squash in as much. So it's occasionally not possible to get down to the specific wire, the swage dimension that it should be. So in certain cases, we would advocate a second parallel swage. Just don't start in the same place. You just start about 1 centimetre further down the swage and roll it again. But you just don't need to roll it through 90 degrees and roll the flash off. Because in doing so, you put a problem in. You've opened up your first roll, but where those flashes roll over become a lovely little home for crevice corrosion long term, which is why we don't advocate rolling it twice at 90 degrees. Any questions on that? Is everybody happy with that logic?
There are nods in the room.
Everybody's good with that?
Yeah.
Okay. So that's how we mechanically swage wire fittings onto wire. So the alternative is what we call the swageless or the mechanical fitting. I'm sure you're all familiar with the old Norseman fittings, which unfortunately are no longer available because they went pop. But the Staylock fitting, Peterson in the UK make product that trades under the name High Mod. Blue Wave do some, and they're all subtly different in how they work. But conceptually, what you're doing is gripping a cone over the center strands of the wire and gripping it into a wedge, and it just all wedges in tight and closes. So those fittings are less likely to cause fatigue issues at the end of the component part, which is why a lot of people like them. It also gives you the ability on blue water cruising boats to solve problems yourself when you're in the middle of the Pacific. and a distinct lack of swage machines exist. So normally recommend to clients they take one piece of wire over length with a fitting or two to help themselves out. Should never, when you're reusing them, we would argue that if the rigging is already 20 years old, it's not safe to necessarily reuse the component part at that age. People do, but they shouldn't really. We can suffer with fatigue in the eye part that screws into that potentially at sort of 20, 25 years old. So it's had to be quite careful. Reusing them at 10 to 15 years should be relatively safe, but always use new cones, new formers on the stay lock fittings, and make sure they are very, very size specific and wire type specific. So make sure that they are using the right component parts. One of the other benefits of the product is, depending on where the boat is in the world, if it's in the tropics where crevice corrosion becomes more of an issue, you can, at year 6, 7, 8, physically undo it, have a look and inspect the wire and make sure there's nothing going on horribly inside, reseal it, reclose it, glue, clean, and carry on using it, knowing that you haven't got anything sinister going on inside, which obviously you can't check with a roll swage machine. Any questions on swageless fittings?
Is there a minimum torque that you should torque the swageless fitting down to?
Did you hear that, Andy? I'm not sure if the microphone picked that up.
Yeah, a good question. And unfortunately, the answer is no. The different manufacturers have different ways of how they work. So the picture that you can see here is an old Norseman fitting, and that required it closed the eye, the wire over the top of the cone as it closed, so required a little bit more load to close it, as does the stay lock fitting. But the stay lock fitting has a former inside that means that the eye can slide, or the fitting can slide around, but the wire isn't graunching. So different loads for different fittings. The Peterson fitting, you don't, it doesn't close the wire over the top, but the wires stay sat in a little bronze crown. So it will be different loads for different manufactured component parts. It doesn't need to be crunched up to death, is the one thing I would say. Just a good sound solid close with the spanners. The glue's going to lock it. Ultimately, if it moves a millimeter or two down, it's just wedging tighter and tighter into the cone format. So it doesn't have to be done absolutely singing bar tight, but just really good and snug, like a normal nut. If you were bolting a winch to a deck, the tension and pressure you'd put on a nut, it's kind of the same kind of level of pressure on 12-inch spanners or thereabouts. Does that answer the question?
Yes, thank you.
Good. Okay.
Oh, another question coming.
Yep.
Sometimes you see galvanized fittings and stainless wire together. Is that okay or not?
No. No, it's you won't ever see a galvanized fitting swaged onto. You might see stainless fittings on galvanized wire. Clearly, you're going to get the galvanic issues kicking off. So if it's in a wet environment, that's just going to be a recipe for a disaster. So we would be desperately avoiding any of that going on. The old, I guess, I mean, we're going back probably 35 years ago. Norsley used to do some galvanized wire that was impregnated with plastic that they used to roll swage stainless steel fittings onto. Jesus, I mean, that is so old. If you see that nowadays, it needs to go in the bin anyway, because it hasn't been made for probably 20 years. But no, stainless and galvanized, try and keep them apart.
Thanks, Andy.
So what are the key things that cause a master fail. Well, I think we all know that sort of normally it's going to be a failure of a wire swage terminal, and you can see in the images there some different issues. Now, for us in Northern Europe, I would say 90% of our wire rigging failures are caused by fatigue. So the picture, your left-handmost picture, you can see a wire strand has popped out. Fatigue is probably our biggest killer. But if you went down to Greece, you would see the biggest killer is going to be crevice corrosion. And you can see there, the next couple of pictures, you'll see cracks running down the swaged part itself. Some of that is just simply crevice corrosions, and it's never made easy, as I alluded to earlier. If you double roll swage, you can cause the fold, which causes this to manifest itself long term. But it's really the change in temperature, that those hot to cold, that causes things to sweat, and at a molecular level, the water molecule gets into the stainless steel and migrates and causes the fissures that cause the cracks. Talking to a couple of riggers that we supply fittings to in Greece, 90% of their wire rigging failures are caused by crevice corrosion. They hardly ever see fatigue. And some other good friends of ours that do what we do in Australia on the Gold Coast. Again, they changed that in Australia. They just changed rigging at year 8, and it's because the less fatigue but more crevice corrosion. So tropical weather, look for different issues. You can see in the middle there's a horizontal crack going around on an eye terminal coming out to a rigging screw. That is an indicator of a really, really poor quality fitting in the first place, which has caused that to occur. So it is crevice corrosion, but it's been allowed to happen because the raw material, the grade of stainless used, and how it's made is just really, really poor. So quality of fittings is going to be a massive issue. Next fitting across, you can see the T terminal. Again, normal sort of failure of some T's. And again, it's just through load application, possibly through alignment, that the wire isn't aligned directly through to the correct fitting and it's not sitting at a nice angle. Some brands are more prone to it than others, partly because the bar stock diameter is smaller on some brands than others. So the old Navtech product, now replaced by Hammer, and Peterson fittings, are all slightly fatter in that head area. So you see less failures of those component parts on different brands. Then the other little fitting there, the picture on the right, you can see that's been basically poorly swaged. So either really, really sort of a rigger that really doesn't know what they're doing, or the machine itself is really, really badly worn, that causes the swages to come out curly. Now, as you can imagine, if you load that, the wire right at the top of the swage has got a lot of pressure on one side than the other, and that will just foreshorten its lifespan, and the fatigue will kick in way earlier than you'd expect it to happen. So it's just not going to last the lifespan that people would expect it to be, which
Oh, well, Andy, we've lost you. If you're hearing me,
is works for some boats. Now, in our world, it works on a typical family cruising boat that's in the water for 6 or 7 months a year. It's out of the water for 5 months of the year through the winter. It perhaps does 1,000 miles a year in its summer cruise and once a weekend, once a month out cruising in bits and pieces. That is the stereotypical boat that will last 10 to 12 years. If a boat does a lot of miles, so if it's a charter boat or a sailing school boat, mileage is the one to start watching, because at 30,000 miles, the fatigue in our area in Northern Europe, the fatigue will kick in. And we'll see it with boats that do round the world trips. That let's take an Oyster 56. They've changed their rigging 1 year. They cruised off down to the Med. Then they've joined the Ark. They've done the Ark. So they're starting in the Caribbean, having done 7,000 or 8,000 miles. Then they're going to go and do a 30,000 mile or a 35,000 mile round trip. It's not unusual for us to see issues on those boats when they get to South Africa, which is not quite all the way around. So we know that the mileage kicks in at around about 30, 35,000 miles as if it's really, really tuned well. So our advice to anybody going off to do around a world trip is change it just before they go, the summer before they leave and head south. Go off and do 1,000 miles or go and do a month sailing, come back and get it completely retuned. So all the constructional stretches dealt with, then they can go away. Because interestingly, tune is really critical. If it's poorly tuned and it's really quite slack, the fatigue life accelerates quicker and will fatigue quicker. You won't get to that magical 30, 35,000 miles, which is the optimum. It will fatigue quicker. People sort of say, well, how do you stop the clock ticking? The only way you can stop the clock ticking is take the mast down in the winter. That truly makes the rigging last longer. But even when the boat's in a marina or laid up ashore with the mast up, the clock still ticks, just slightly slower than when it's sat on the mooring or when it's going sailing. So if you want the rigging to last 12 to 15 years, then for 5 months of the year when it's out of the water, mast needs to be down. And then it stands a chance of lasting that 15 years. Does that help on the wire fittings?
I think general nodding again.
Any questions on that? Any experience?
I've got a guy sitting in the room who you don't know, Jeff Waddington, but we have been talking on and off over the last couple of days about products coming from the Far East.
Yes.
Do not meet the qualities that we would expect in the UK and probably Ireland too. And
100%, I'd agree with that. So our issues there, as you can see that little middle picture with that eye, that is a Far Eastern produced product. Now, we can't put everything that's manufactured in the Far East in that same category. So, for instance, the very best stainless steel wire that we all use comes out of a factory made by COS. They're in Korea, right? That is 100% way beyond anybody else's levels of wire, the very best wire you can buy. All the hammer fittings are all made in a factory in Thailand, but incredibly stringent products in there. Flip side, there are other brands, and I'm not going to name brands because that would be really unprofessional, that are Chinese manufactured, and we know that because we see it on the conformity forms, so we know exactly where they're manufactured. Now, the issue we all have with buying products in China is you are never 100% sure whether your 316L is 316L or whether it's 306S or 304 or whatever. And when it's sat in a box being used in a warehouse or in a factory or in a rigging loft, it looks all the same. And it's 6 months in, 9 months in, that you then discover that it's not. And that's when it all starts to tarnish and go wrong. So yes, it's quite tricky making sure that we're not using the wrong products, or at least you know that the quality of the product is really, really high. Nick, for instance, when he sells a hammer product, all the wire leaves with a certificate of manufacture for the reel of wire. So we absolutely can trace it all the way back. You know how, what, where, when. And in that factory, they only work with 316 stainless steel. So there is zero chance of contamination from the machinery that was possibly rolling 304 or even a steel product yesterday. So you don't get that little issue of one strand going brown, which is a sure sign of contamination in the factory when the wire's made.
Thanks, Andy. Jeff's looking, giving me
Hi,
that.
sorry, gents. Can I just jump in as well? Something to hi, everyone. I'm Nick from
Hi, Nick.
TMS. I spent a lot of time traveling around Europe talking to riggers, and one concerning thing which Andy alluded to then is certain elements of components which are majority manufactured in Europe are sourced from China. So certain clevis pins, the small commodity part in a much bigger rigging screw is actually of Chinese origin, which is a load-bearing part. So it may look like it's a European product, but some of the actual structural parts, components are there, are Far Eastern source. So it is really a grey area, and you've got to pay a lot of attention to where the product's actually coming from.
Thanks, Nick.
Okay,
We
we can come back to this with other questions at the end if needs be. So I'll keep marching on.
Please do.
Rod rigging. So just quickly, how is it made? How is it formed? So on the left-hand side, you can see a plan view of a small rod press with two big hydraulic jacks on the unit. So what you do is you push the rod into the machine, and those dies that you pass it through have a little sort of recessed shape, absolutely specific to a shape that matches the fittings. So you can see here what we're not doing is pressing the fitting onto the rod. All we're doing is forming a head on the end of the rod, which then holds a component part captive. It can't fall off, one thing or another. So the rod comes in and it pushes up against the head cylinder, and the side cylinder comes in and clamps the dies. So the dies here are now clamped tight against the rod, and a very, very specific distance of material is left between the head cylinder and the surface of the die. The head cylinder then comes in, and you can see this just starting to oval out as the rod here in the fourth picture across, and it fully pushes in against the dies and pushes that exact amount of material in, which then creates what we call the head shape on the end of the rod. Then release the side one, give it a shake because they normally grip quite hard in the dies, and you then have the rod with the head shape on. Onto that, we then can fit all the component parts. So unlike a wire with a swage fitting put onto it, it's mechanically put on and that's it, you can't take it off. With rod, the head is not mechanically fastened to the component part. So whether it's a rigging screw or an eye or a stud or a stem ball or whatever it happens to be, they're loose. One of the benefits of that is when you come to do a re-rig or an overhaul of rod rigging at year 5, year 6, very often most of the component parts are safe to reuse. So the cost to redo a rod rigging is never quite as much in those intervening years. Same rules, the time you get to year 20, the component parts, you probably, and if it's done a lot of miles, you wouldn't want to be reusing. So that's the 3rd or 4th re-rig. You would probably be replacing all the component parts at that point. Possibly not the tip cups, which are big, lumpy and expensive materials. They can be very easily non-destructive testing with a die pen test. And if there are absolutely zero cracks and no damage to the threads or anything, they can safely be reused. So that's kind of how we make rod. One thing to understand, rod rigging is not made of 316 stainless. It is, it's an alloy actually. The brand that we use, that we're all familiar with in our industry, is Nitronic 50. That is a brand, it's an American-owned brand. It's a very specific alloy that makes it incredibly hard. So you guys, if you had a hacksaw and you had a bit of 316 bar, you could cut through that fairly easily. If you had a Nitronic rod in front of you in the same vise with the same hacksaw, it would take you probably 3 times the time to cut through it with the same hacksaw blade. It is so much harder than 316. And it's chosen largely for its characteristics of ultimately strength because and stretch. So it's strength because it's quite happy to have those head forms created, that they're cold formed, and they hold load up to the day they let go. But if we did that with 316, for instance, it'd be very easy to form the head, but the head shape will deform under load. So that's why we use an Artronic. It isn't quite as corrosion resistant as 316 stainless would be, as wires are. So it's not unusual to see them what we call tea stain, slightly brown. That's not unusual. It's just a characteristics of anything. If you use duplex or 17-4 grade stainlesses, they just have a different chemical composition, and as such, corrosion can occur in tea staining formats, easily polished off. What are the failures of rods? What caused them to fall off? So here's some pictures here. Obviously, the right-hand picture you can see is the head has come off. That's probably the most common issue. Is nearly always going to be fatigue related. Yeah. It's the issue we all have with rod. Surveyors are exactly the same as riggers in that context, is you can't see the head inside the fitting on the mast. It's hiding. The only way we can expose those heads is mast down, rods off, fittings unscrewed, moved back out of the way, degrease it, clean it all out, polish it off, and then we can see the head for what it truly is. The second picture across from the left, you can see a lot of chatter marks. And that's just simply because that head shape was the wrong head shape was used in the wrong fitting. So Navtec, BSI, OYS, the old Regana, they are the principal. Regana is no longer, OYS is no longer, but there are 3 different head shapes on rods. On smaller rods is not a problem. They're all close enough that the convex shape fits most of the fittings. And by smaller, I would say rods up to -40, which is 10.1 mil. Anything bigger than that, so you're on boats of 50 foot and upwards now, that might be -40 at -60, have to be the right head shape. So the right dies have to be used to match the right fittings, because that's the chatter that you get, and that will clearly cause that to fall off sooner than it's expected. Left-hand picture, you can see some just really badly made rods heads. You can see the left one there, a little flash mark. So in those dies, when it comes together, there's you can get a flash mark. That flash mark has to be polished off, ground off, so that you get a completely even profile. If you don't, that causes a dent in the fitting that it's sat in, which means it isn't moving as it should, and it can cause that to then fatigue prematurely. The right-hand picture just shows an off-center head, again made with some machinery. Locating the dies isn't automatic, and if you just put it in on the squit, you just push the head off to one side. And again, it's just a failure. It's going to cause putting more load on one side of the rod than it should do, and will cause a premature failure of what it should be. Occasionally, the third picture, you can see a vertical crack coming down through that. Less critical, sometimes caused from cheek bar. It can be hiding in the raw bar stock from new. But can occur from load application, from overloads, and again poorly fitting component parts to the head shape. Don't see them very often. Normally, you'll just see the horizontal cracks, which are we do a dye pen test on the heads, and it'll highlight those really quickly. The one thing with dye pen testing and visual inspections of any kind is it doesn't tell you what's going to happen a week on Thursday. So it might tell you that it's absolutely fine today, but if it is 8 years old, just because it's fine today does not mean next week it is going to still be fine. At 8 years old, the advice has still got to be to the client to rehead. And quite often we can simply cut that head off and reform a new head and reuse the bar and reuse the fittings. That's the beauty of rod, that makes life a little easier. Any questions on rod rigging?
What's the interval for change of the actual rod itself?
I didn't hear that one.
Okay, the actual time change
Yeah, the rod.
on the rod.
Sorry, somebody just been very naughty and dropped something on my desk. So I missed
All
that.
right.
Sorry.
What is the time span that the life of the rod?
So the rod bar stock itself, I mean, it no reason what is really, really rare to see a failure in the middle of the rod. So quite successfully, if you could solve the problems of losing length, no reason why the bar wouldn't carry on working for 20 years or so. But each time you rehead it at year 5, year 6, year 7, depending on the kind of type of boat, you lose length. And in rough context, you lose a diameter to chop the head off, because that's how much length is the depth of the head is about the same as the diameter of the rod, and you need roughly the same amount again to reform the eye. So on a 8mm rod, you're going to lose 16mm at either end. So you can lose 32mm if you're reheading a shroud. Now, on a V1 or a D1, you might have that adjustment in the rigging screw fairly easily. On a V2 or anything further up the rig, especially the fixed length stuff, you don't have that length. So it's difficult to just simply rehead the ends. What we quite often do is we move rods around the rig. So if a D2 and D3 are the same diameter, but one's 300mm longer, then we just move the D2s into the D3s and reuse the bar stock completely. So that's all very easy to do. We quite often use the backstay to make up a couple of V2 D3s because there's enough length in that to do that. And we do have some clever little fittings. So on forestays on bigger boats, when the rod starts to get quite expensive, we're kind of keen to try and reuse it more often than not. So we have slightly longer eye terminals, so we can. It's cheaper to change an eye terminal than it is the whole rod. It's kind of how we get around that.
Any other questions? No, all good. Thanks, Andy.
Okay. So moving away from wire and rod, obviously the other thing that causes masts to fall out the sky is the mast itself, mostly from corrosion. Masts that were made 40 years ago now had a lot of stainless steel component parts riveted onto an aluminium tube, and over time, clearly the barrier paste breaks down, dries out, becomes less effective, and therefore the two materials with salt water fizz away. As you guys know better than I, the results are normally catastrophic. So that's the biggest one to watch. So when you're doing surveys on rigs that are certainly probably 30 years old, that's when you I would say probably from late 80s, early 90s, we had moved away from stainless fittings and had more aluminium castings on aluminium fittings, so less of an issue. That corrosion doesn't just exist behind stainless steel. It can happen behind rubber materials. So the picture there, on the third picture in the middle here, is showing the corrosion from behind a rubber gaiter. And natural rubber products are really, really bad. So Kemp back in the 80s used to use a black rubber chalk for its vertical pole stowage. And 99% of the times we used to take those off, there was a really big hole in behind. And unnatural rubber gaiters cause problem. Get a little bit of moisture in there, sat in there, festering, it causes a problem. Clearly dents are the bane of our lives. If there is a kink or a crease in the tube, it's dead. Because it just won't be able to withstand the compression that the rig is under all the time. It's a weak point and it will buckle at that point. So interesting, I did a presentation, this presentation, a similar one to some insurance companies recently. And they said, yeah, but you could put a patch on that. I said, yeah, we could, but it won't come with a warranty. And I said, and that's where it all falls down, because you want us to do a 500 quid repair to save you guys spending 10 grand, 15 grand on a replacement. What happens if it falls over in 9 months' time? We expose ourselves to a 20 grand claim for a 500 quid repair. The risk reward doesn't stack up, which I think was the first time that kind of dawned on them, really. So I think that's an ongoing conversation. I sort of said, you need to treat a repair as a get you home, get you out of jail, temporary fix, rather than a full all singing, all dancing solution to a problem when you've got a dent in the tube underneath. I don't know how you guys all feel about that, and I'm sure you've all had experiences of when you've had an insurance company who's been quite amenable to a solution, and those that are really, really reluctant to ever put their hands too deep in their pockets.
Yeah, I've had quite a few of those, if I could just put in there. And I mean, the last one was a little bit contentious, really, but if there's any shock loadings to a mast, they instantly write it off. So, I mean, we had one where a yacht came out of a hoist and the one of the top shrouds got caught on the hoist as it came out and twanged it a bit. That was it. They just wrote the whole rot off, replaced the whole thing. It was on a fairly new boat, so I wasn't too surprised. And I just had one just this back end in one of the storms we had where the boat was blown over and the rig did impact on the little motorboat alongside. We don't know to what extent, but it did graze the little motorboat a bit. Instantly, they wrote off the whole rig, which was £16,000 worth of rig. Couldn't find anything wrong with it, but nope, that's it. Sorry, it's a write-off. So whole new mast, whole new rig. You know, it's just made me wonder, really.
Okay, my personal view on that is the nice thing about an anodized aluminium tube is the anodizing will give you all the clues you want to find. If there's any excess load been applied to aluminium that you can't physically necessarily measure or see, you will see it in the anodizing. The anodizing, if there is a highly loaded area, let's say on that cap shroud but caught on the hoist, let's say the cap, the fitting in the mast, the keel shell or the T-terminal backing plate, if that had been subject to an excessive load, the first thing you'll see is little white crazing in the anodizing. And I think the minute you see that in the anodizing, I think you're absolutely right at that point. You bin it, because you're not quite sure how much load and how far it's necessarily moved in. But if there are no stressy marks in the anodizing around any load point, and there's no kinks, no dents, no things, then I think it's probably safe to reuse. But we, like you, if a boat runs aground, goes from 8 knots to 0 knots in the space of a foot, but everything looks fine and dandy, we won't put the mast back in the boat when it comes out of the shed. And we have that conversation with the insurance company and say, well, can you tell us where the load went? Because we can't calculate which way the load went. So every single wire on that rig, we know has potentially taken excessive load, and we don't know which one it is. So we would always advise in a significant grounding, just change all the standing rigging. It's the only way you can be 100% sure it's not going to fall out of the sky.
Andy, I'm just going to let David Mossman in, but keep going. We've still
Okay.
another 10 minutes or so.
So some conclusions. So hopefully you can all see that. So with wire rigging, basically try and change it as in rough context around about 30,000 miles, 10 to 12 years. But as I say, the caveat to that is if it's a charter boat that's doing 20 weeks a year, probably want to be year 5, year 7 is get it changed. If it's that 10 years is really just a stereotypical family cruising boat, Sadler 32, that's sort of I've just chosen that boat for no any particular reason, but it lives on a mooring for 6 months a year and it's in a yard for 6 months of the year, but they don't take the mast out very often. But that's a good indication. When rigging is changed, make sure that every component part in its length is changed. So we had a scenario recently, a charter boat in Scotland had a forestay changed after 12 years. The rigger didn't change the strap toggle at the top and bottom of the forestay, of the furler, just changed the wire inside the furling gear. And it was no great surprise that within about 6 months, the strap toggle had then got to its end of life and fatigued and cracked, and the mast fell out the sky and wrote the mast off. So 25 grand claim for the sake of a 46 quid toggle. So and the insurance company had nowhere to go. They had to pay it. Clearly the insurance company might be having a conversation with the rigger involved because the advice was probably not as good as it could have been. But difficult to win that one. But our advice to everybody, Nick does quite a lot of seminars to the industry, to the riggers, and makes a page very specifically about this on furlers, changing link plates, extension link plates as well, should all be changed. If they're in the rig load, they should all be changed at the same time, and definitely split double jaw toggles should all be changed. The tuning of the rig is really important. We see time and time again, clients, they'll have a re-rig and then they just disappear. They don't come and find us, they don't come back. Whereas, and every single client we will say, come back and see us in a month's time, or go and do your first little sort of passage and then come back and see us. Because we want to be able to take the constructional stretch that will happen. So when a wire is formed and made and it's then put on a reel, when we make it in the workshop, it's just come off a reel. It's not had any load applied. So put it in the boat. The boat's been ashore for 6 months. So the whole thing just changes shape. Boat comes up, wires get longer. So we then need to be able to retune it and take that stretch out. It may only be a couple of turns per rigging screw. It might be 3 or 4. But we then know that it's properly correctly tuned and isn't then going to be sat wobbling around in the breeze. And again, as a guide for you, and every boat's slightly different, but if we took, say, a Bavaria 34, is probably at comfortably full power conditions at about 13, 14 knots of breeze. So full Genoa, full main, not got too much weather helm, flat water sailing along. At that point, go to the leeward rigging. It should wobble about an inch or so either side of vertical. That's most boats, sort of up 40, 50 feet. If it's tuned correctly, in that sort of 12 to 14 knot window, when it's bowling along upwind in flat water, wobble an inch or two, no more than that from vertical. And that's a fairly good indication that it's about right. Not always, you can't achieve it on every boat. There are certain boats like Moody Eclipses that you can't put rig tension in because you can't open any of the doors downstairs. But most boats, that's what you're trying to aim for as a guide. If it's slacker than that, it will just simply fatigue quicker and its lifespan will be foreshortened. the boats that, as we alluded to earlier, the Oyster 56 that gets rigged, clears off down to the Canaries, it's done 1,000 miles, owner doesn't touch the rigging, trundles across the to the Caribbean with about 3 ton of extra kit on the boat because he's just put every spare known to man and his scuba gear and everything else. He's going to end up with stranded wires by the time he gets to the Caribbean. A, because he hasn't retuned it and taken the stretch out of it, and B, because he's now overloading the boat and the displacement of the boat has gone up significantly, more than its design parameters. So when it's heeled over in 20 knots of breeze, the boat is stiffer because it's got more weight down low, and therefore the wire stretches more and the leeward rigging wobbles more. So again, probably every winter we see a boat of our customers, not every winter. In the last 10 years, we've had 3 boats get to the Caribbean with a stranded wire normally on the lowers. For us, the way of solving that is upgrade the wire to a higher strength wire so it stretches less, and you have a greater safety factor in the wire that you're working with. So we did a Contest 41, re-rigged it with 10mm 119. It's going back to about 10 years ago. 6 months later, they were in the Caribbean and they had 2 lowers stranded. So we made 2 new ones, sent them to him. And on the trip back, he had exactly the same problem with one of them. And at that point, we said, well, hold on, we're looking at the boat. Your boat should weigh 11 tons. He said, no, we weigh 16 tons. I said, well, how do you mean you weigh 16 tons? Well, the last time we lifted out in Lisbon, we know we weigh 16 tons. So, well, that's, it shouldn't be. He said, yeah, well, we've got a lot of kit on. So we changed his wires then to a Hammer Pro, which moved the wire breaking strain from 6 tons to 7.5 tons, and never had a problem since. So there are ways around it, but we just need to know what people are doing. But tune, really important. Servicing of masts. Everybody seems to think that, I mean, when I started in this industry so many years ago, aluminium masts had replaced wood and they were going to last forever. And stainless steel wire rigging was going to replace galvanized, was going to last forever. All the problems had gone away until we then had galling problems with the stainless steel rigging screws and couldn't undo them. And then we started getting the fatigue issues with wire stranding. Early swages didn't have a relief on the inside of the swage, which made it worse. Current design is much better, but things don't, contrary to most customers' belief, last forever. And at 30 to 40 years, we strongly recommend a mast is fully dismantled, stripped, serviced, sorted, corrosion dealt with, refastened, new sealer and everything else. So the question is, how long does an aluminium mast last? 30 to 40 years, but you can give it a big birthday and expect to get another 10 or 15 years out of it. If you've got tea staining on your rigging, on stainless steel component parts on a boat, 3 reasons for that to be occurring. Generally, it's atmospheric. So shipyard across the road or local fishing boats been grinding, and so there's ferrous metals that have contaminated the boat, and normally is visibly as spot dusts, spot marks. One of the quite common ones, when you get an even tea staining on more than one wire size and more than one, and it's on component parts and wire, it's very often earth leaks that cause this problem to occur within stainless steel. So if you've got a boat that's got 6, 7 and 8mm wire, and you've got an even tea staining on all 3 wire sizes and the component parts, you've got an earth leak. That's not contamination because it's not spotty, and it's not a poor quality product, because the chance of you having a poor quality 6mm, 7mm and 8mm wire are slim. And if it's on the fittings as well, first place to look is an earth leak. Above my pay grade, I've no idea how you find them, but it's normally the indicator. And then the third reason is just a poor quality product in the first place. And we spoke about that earlier with the Chinese products. strongly advise customers to take a mast down every 5 years. They won't, but the advantage of having it on the ground is you can visually see things that you can't see with the rig in the boat. You can look at spreader routes, you can look at the wire fittings properly, you can take the keel shells out of mast. All of those things that when we do a visual rig check, and you guys, when you're doing them as well, you physically can't see some highly critical, highly loaded areas with a rig in the boat. Keel step rig boats, you can't see what's in the partners. So 3 to 5 years, have it out. Should be professionally checked over at that point. And obviously the client must do an annual visual inspection top to bottom to make sure that pins, split pins are siliconed up, and a little cracked sheave now, change it while it's got a little edge chip off it rather than it wrecking a 400-pound Dyneema halyard is obvious, but most owners don't see that. Any questions on that?
No, no, all good. Question
Yeah,
time.
you guys
Yeah,
are-
we got a question. Hang on.
What do you suggest how to deal with corrosion or aluminum mast? So what like products you recommend to use?
Did you get that?
So corrosion on an older mast.
Corrosion on
On-
aluminium masts. Any
Okay,
tips,
so
advice?
if you've got visible corrosion away from a fitting, just in the middle of the tube, we need to try and understand why it's caused, how it's happened, and why it's happened. And I guess possibly that's happened from when a mast was stored badly with stainless steel wires left running along the side of it. It's difficult to do anything with. You can't just strip it, dismantle it, re-anodize it, because anodizing doesn't cover anything up. It's not a coating; it's a treatment of the outer layers of aluminium. So any bruising, any marks will stay there. If you've got corrosion under a stainless fitting, as we had in some of those earlier fittings, some of those earlier photos, if I just scroll back and see if I can, on that one, it's very difficult to, you can't treat the corrosion. All you can do is put additional material back in, whether it's done internally or externally, to deal with the material that has disappeared and been eaten away. If it's not structural and it's just edged a little bit off the outside, it's on a 5mm wall and it's just nibbled 1/2 mm or something in a little area, then not grind it out, but really scrub it out and get the corrosion out, treat it with a chromate paste, and you could put chemical metal just to aesthetically make it a little bit better. But if you're putting a fitting back over it, then instead of just using Duralac, use a frame sealer that then fills all the holes to stop water getting back in it. That's probably the only advice that we've got, really. But if you're starting eating 1/4 of the mast wall away, then you're into patching or throwing it away, depending on where it is and how it is.
Thanks, Andy.
So I'll leave that one up. You can just read it.
Another question coming for you. Another question coming.
Andy, can I have your opinion on sleeving?
Opinion on sleeving.
What? Because the mast is jointed, there's no problem if the sleeve is made correctly, and it's of the recommended required thickness, and it is able to do the job of the tube, and it's correctly fastened and put in a way. In most cases, it's okay. You just wouldn't put it in a highly loaded area. So you're trying to avoid putting it at you wouldn't put one at a gooseneck. You wouldn't necessarily try and put it slap bang at a spreader. You might put it above a spreader as long as the spreader is very well supported. So it's in the design of the sleeve. There's no reason why a sleeve can't be used as long as it's engineered correctly.
That answers my second question. Sleeving for air, most repairs happen gooseneck or the root of the spreaders, so obviously it's not an ideal solution.
Yeah,
Okay.
if it's at a highly loaded point on the rig, and anything between sort of if it's keel step, anything between the keel and the first spreader, we would call that all a highly loaded area. But on a deck step, from deck to the spreaders is a really highly loaded area. If we do the analysis of a rig design, and you push the limits and it's on an FEA analysis, it's red 3/4 of the way up to the lower spreader. So that's an area you just need to try and avoid putting it in those areas. That said, we make some custom masts for the 6-meter class, and a lot of those boats end up in containers. So we've got a join at 12.2 meters, which is a meter above the gooseneck. But we've engineered the joiner incredibly well to do that. So the joiner itself is way stronger than the tube, so that we are dealing with the problem in that particular area. So it can be done. Just you try and avoid the high stress areas.
Thanks.
Thank you. Any other questions?
There you go.
Andy, thank you. Great job. Really appreciate that. And thanks for giving up some of your time today. And also, Nick, I look forward to catching up with you next Tuesday. No final points. Otherwise, I'm going to say thank you, guys. If you want to stay for the next presentation, that's up to you. It's fine. Leave that decision with you.
I'll just put one thing out there. If anybody's ever got a question that they are stuck with when they've got a survey, I'm more than happy for you to share my email address with your team there today. I'm more than happy if somebody wants to drop me an email and get my thoughts and ideas on something. More than happy to help and offer advice.
That's great, Andy. Thanks. I'll get head office when we write back to the guys in the next day or two to actually include your email details. So thank you very much indeed. Could I ask you to stop your share now, please, Andy?
I can stop share. You're done.
Fab. Thank you very much indeed.
I'm going to leave you in because I've got to rush off to an airport. So any questions, throw them to Nick.
Thanks very much.
Thank you.
David, good to meet you virtually.
Good afternoon. Nice to meet you.
How are you?
Yes, doing really well. Looking forward to this.
Excellent. And I can see you've got Rob, who I don't know either, online as well, but you're very welcome, Rob.
Yep, I think Rob's seeing you in person next week.
Indeed.
Yes, indeed. Hello.
Fantastic. Hi. So you've got permission to share a PowerPoint if you want to open up and share the screen.
Yep. Share that. Okay. So, right.
I'm not seeing anything yet, David. Not seeing your presentation.
Right. Okay. My sharing says I am screen sharing.
Just try again. It's the system. It's IT. We know what it's like.
We did this a lot through COVID.
Oh God! It's just stop the share and try again. Sometimes it just doesn't connect.
Very generous offer from Mr. Allspars. I was well impressed with that.
Which generous offer?
Well, he's always on the end of a line.
He's always on the end of a line. Yeah.
He's going to wish he'd never said that. I'll tell you.
You might find he always is.
Still not seeing anything, David.
Still not seeing anything. Right.
Getting phone calls or emails left, wrong,
I can see the presentation when,
well,
you share. I don't know if I'm the only person.
Really bizarre.
It's been popping up for me pretty well as well.
That's bizarre.
So Rob, you can see that, but no one else.
Yeah, I think Nick and I can see it.
It's a bit odd.
That's very curious.
That is very, very peculiar. Do you want to try it again, David?
Yes, I will turn it off, turn it back on again in true IT style.
These days, I always say every time we go anywhere, I just apologise before we start for the IT gremlins, because they're always IT gremlins. Just the norm.
Have you got that? Anything on that?
No,
Yes.
not seeing anything. Why
So
are the
Rob,
options?
you've got it, but no one else
Yeah.
has.
I've
Okay,
got David.
okay. So it is right. That's kerfuddling.
Just
Do
say that
you?
David, sorry, just jumping. The video is lagging from IIMS, so it might be just a connection. Just needs a bit of time to catch up with it.
Okay, yeah, I've had this when I've dealt with the States. So,
Now we have it.
okay, so now I'm going to play from beginning.
It's obviously come from a long way away.
Come a long
It's
way
taken
away.
time.
Yes, exactly. Yeah.
Yes.
So without further ado, David,
pigeon.
we can
Okay,
see you.
great. Let me know how long the lag is. Otherwise, I'll change slides and it won't link up. So let me know how far behind I am. So right, okay. So what I'm going to chat to everybody about for the next kind of half an hour, 40 minutes, is really the rope and the running rigging elements, kind of that connectivity that's so important to all of our customers, and really try and arm everybody with a bit of a picture book of what am I looking at when I'm looking at rope on a boat, from my perspective and my background. So we're kind of splitting rope down into sail controls, which is halyards, outhauls, and control systems, and then we're looking at Genoa sheets and main sheets, and systems for control. And then there's obviously the safety and security, peace of mind element, which would be mooring lines, and all of those elements. And really all of that, I would hope that you'd walk away with a slightly heightened level of confidence in what you're looking at when you're approaching a boat. So I've split this down into kind of what you're most likely to be looking at when you're assessing somebody's vessel, and the three kind of main products that we are all still working with and everybody is still sailing on. So at the very bottom of the, let me just turn the pointer on. No, let's not do that. It's been a while since I've done a Zoom. So the rope at the bottom of the page with the blue fleck. So this is the double braid product, and this is the majority of what every Jeannot 35, Moody, Hunter, everybody is majoritively cruising on still in the UK. So double braid is a polyester braided jacket by description and a polyester braided core. The takeaway from this product is it's got better and better with time as the quality of polyester has improved. So we see double braid used as the general purpose rope, pre-stretched, heat set. It's load bearing in its core and in its cover, 50%. So it's a really important rope to watch from a wear and tear point of view, because as soon as that cover is damaged, then you're eating into your brake load of the rope. The next product up is one of the older products as well, which is Marlow braid, but there are many other versions of it. And this has a 3-strand polyester core. It elongates a few percentages less than double braid, but the gap between the two has narrowed over time significantly. The rope at the top is really the one that we need the most commentary on, because it is the product that's brought the most change to everybody's sailing. And that is the red rope at the top is a Dyneema core, which is 12 strands, and the polyester jacket. The polyester jacket, now that we've moved into Dyneema, is there just to protect the core. All of the load bearing is happening through the core and nothing through the cover. That's really just the protection device. And I'd say Dyneema has been the bigger change in that we've all been sailing on polyester since we were extremely small. And the failure mode of Dyneema is very different to polyester. So let's have a little bit of a chat about Dyneema and where you might see that. On the left, you've got one of the clipper boats. Now, Dyneema has some fantastic uses because of its low elongation and its incredible brake loads that you can generate. We tend to use it in this capacity on the left instead of a bottle screw on the forestay on the clipper boats. So you can see the level of responsibility given here. This is a double tape system. So there is 5 laps of 11 mil max Dyneema in here. And then there's another strop underneath should that fail. The reason we use it in that capacity is because as these boats slam upwind, the bottle screws can hide all sorts of sins and failure. The Dyneema is very easy to inspect. It loves to be used in a strop format. And we find we change these in Australia. And when we take them off to just swap them out, because obviously the price is massively reduced, we find that the brake load is 20% higher than when we put it on, simply because the fibers have all aligned. And Dyneema is really good in that aspect. What you wouldn't use Dyneema for is for the entire forestay, because Dyneema does not like, it doesn't like abrasion, it doesn't like anything sharp at all. It doesn't like heat. So all of those elements mean that it's not great for structural standing rigging if it's being touched by anything else. So you'll often see it in a lashing format on the right and a lashing format on the left. So this is where we tend to see Dyneema used. You can then see it used in all sorts of adjustable fittings as well. It's very robust for UV. You'll get 10 years of UV life out of it. UV is tricky with braided products. Obviously, by nature, we've got layers of fibers. So UV is very much attacking the outside of the rope, but not massively degrading the inside of the rope. So UV damage to rope is quite difficult to judge. The reason we don't use Dyneema in a Bavaria 34 as standing rigging is because of the vulnerability of it. You can do it to give you some scale of the weight saving. So the picture on the left is a tiny little 2.4 miniature keelboat racing boat. So we took, by replacing all of the stainless steel wire rigging in a 2.4, we reduced the weight in the rig by 2 kilos. So you can imagine what you can achieve if you use Dyneema in a yacht rig. It would be huge. The problem is the vulnerability of Dyneema means it's not ideal for shrouds and forestays. You would only need to wrap the Genoa sheets around it in a squall, and the heat that they would generate around the shrouds, you wouldn't have a rig left. So where it is good is for strops, as we discussed, but also for backstays. You'll find Dyneema in a backstay as quite a regular thing on most boats these days. It has very little interaction with the rig. It might touch the top batten, in which case most people apply a little chafe cover to protect it. And that's really, really where we see wire replacement on standing rigging on cruising boats, is mainly in the backstay and possibly in some lashings. And that's about it. On the cats, we see quite a lot of catamarans with Dyneema rigging with chafe covers on it. Because the rig is freestanding, it's not touching the shrouds, it's on a rotational mast, and it's not under tension. And that brings me to the next problem with using Dyneema in rigging, is tensioning. So Dyneema does 2 things. There's constructional stretch, a lot like Andy was explaining, that you need to retune a rig after you've done your first trip. When we braid a rope together, there will always be constructional elongation when you load it up. The problem with Dyneema is once it's loaded, after 24 hours, it will then elongate a second time, which is called creep. Creep is only really relevant to anything that's loaded between 16 and 24 hours. For dinghy sailors, it's not relevant at all because the rope's not loaded for long enough, and the same for sheets. But for halyards, standing rigging, it becomes a problem. So that elongation after 24 hours can be between 0.4% and 1%, depending on the type of Dyneema. And that's sort of another whole subject. So for standing rigging, again, when you watch the YouTube forums of people in the Caribbean who do this, you'll see them with all of their rigging attached to a winch. And between hot and cold climates and humidity, people are adjusting their rigging regularly. So if I'm approaching a monohull boat which is covered in Dyneema rigging, I'm really going to want to know who's done it, how long it's been there, and refer it to an expert, because it's not something that anybody other than a rigger should really approach. And if you're looking at it secondhand, then really that just needs completely qualifying. It's not the UV issue. It's everything about the splicing, the interactions where the Dyneema hits the tips of the spreaders, and all the terminations as well. So Dyneema rigging in monohulls is, I'd say, not something that we recommend at Marlow, just because of the vulnerability of the rigget, of the fiber. But many people do it. I can't say I've seen one in the flesh, but I've seen a lot of coverage of people who do it. So I hope that gives you a good feel for that Dyneema rigging question, and I can take questions on that at the end as well. When you're looking at Dyneema, it has some telltales to it. Obviously, a broken fiber, as we can see in the middle picture, is really quite obvious. And that means it's just been loaded and touched something sharp. And if any fibers are broken off, then there's loss of brake load. The more interesting picture is on the left. This is from Concise, and she's an extreme version of Dyneema in rigging. Her rig cants to windward, and it's canted on this extremely large piece of Dyneema around a sheave. So as the Dyneema goes backwards and forwards across the sheave, being pulled by a hydraulic ram, what we see in the picture on the left is something called bend fatigue. And this is really where the fibers are working against each other internally, so you end up with an internal abrasion. Dyneema is usually very highly coated. Good Dyneema, if you push it apart, you should see it glossy, and whatever color it's carrying should carry right into the core. That's critical to stop this kind of failure that you can see in the left-hand picture. All of the hooking and the fluffing internally is the fatiguing of the rope, and you can only see that from the inside. The picture on the left is cold molding. If somebody has larks-footed a Dyneema halyard onto a shackle, it quite often under load almost absorbs the shackle and cold molds itself onto it. It looks a little alarming, but in no way is it a problem at all. It is just the nature of that modular fiber that it melts itself, and it isn't molten. It's just bonded itself onto the shackle. The trick is not to try and inspect it, but to leave it. We don't recommend you pulling Dyneema apart in that sense to inspect it. So that should give you a couple of pointers on what you're looking at when you're looking at Dyneema. So I'll come back to this more at the end, because there are some really key takeaways to Dyneema. What I'm going to talk about now is the kind of things that when you're doing a standard boat inspection, you know, from push pit to transom, what you're going to see and what the rope is telling you. So rope is obviously textile. Rope is manufactured by twisting yarns clockwise and counterclockwise and then braiding them together to give you a round rope that's balanced with a good amount of twist in it, which gives you the abrasion resistance. So rope is usually always the first thing to tell you when there is an interaction with hardware, whether it's winches, sheaves, as Andy mentioned, or alignment with blocks, clutches, and all these other items. It will give you a telltale fairly quickly if something is wrong, either with the piece of hardware, and on the left we're looking at this Spinlock STX, and this is true of other clutches as well. So the photo on the right is a fairly abraded cover, but it's almost chewed, and you can see that visibly. The fibers in the cover are quite short in their break, and it's fairly even all the way around. And this is one that's been sent to me, and I've gone to the boat to inspect it, because when we build the covers here, that's a Dyneema racing halyard with a polyester cover. So we know the failure mode of that cover because that will have been cycled over a hexagonal bar under load, and it would take approximately 3,600 cycles plus to make that cover fail. So when you get a picture like this, you know that actually there's something inappropriate in the hardware. So on investigation on the boat, this is up in Scotland in James Watt Dock, in about 3 degrees, even though the sun's out. When I pulled the clutches up,
Some of them.
yes, yeah, definitely middle of summer for there. This is what I found. And it isn't that these worn teeth are damaging the rope, but what it means is the entire clutch isn't holding evenly on the rope. So therefore, the fibers are being twisted through in an unbalanced way, and that's what's creating the tearing. My questions on this, and this is quite race boat specific, was, has this had a Technora halyard in it at any point? So this is the Genoa halyard, so it's being hoisted very regularly. And the answer to that was no, since new, just a polyester halyard. So just polyester running through this clutch has done this damage to the aluminium in the teeth. And it's quite common when people see a damaged piece of rope, they will replace the piece of rope. And it's really important, if there is damaged rope, something's caused that, and you really need to investigate that, because that problem will just keep coming, and it will only ever fail in 38 knots when you absolutely don't want it to. So it's really important that that maintenance of rope is managed, and anything that looks damaged, that you locate that source. No one likes changing these clutches because you have to take the headlining out and you have to take the whole unit out, and it takes a long time, and that's why people don't do it. But if people change halyards, they need to change clutch inserts at the same time. So in terms of other giveaways that rope will tell you what's going on, this is another example. So again, a polyester cover on a Dyneema core. The giveaways to this are basically leading in from the left-hand side of the image. There's a big pick of yellow rope in the far left. And as you come into the bottom of the winch here, you can see I've put these red lines across the yarns. So this instantly tells you that this has been cut. So as the rope loads up against something sharp, the fibers have been cut at 90 degrees. And you can see the picking on the drum above as well. As the rope is loaded, the situation has got more and more extreme until it's failed. And like with all of these things, the failure mode has been something sharp. I believe it was in the clutch. And as it's loaded up, it's failed. And it's quite easy to find that failure point just by whoever was operating it and measuring it back. The knock-on, this is the second halyard that they did it to. The first halyard, they just like for like replaced at 300 pounds plus. On the second one, they lost the asymmetric under the keel and the bowman over the front trying to retrieve the asymmetric. You know, so this maintenance of rope, because of the way rope sits in the process, it's always related to sail handling or maneuvers. When we see failures in rope, if I go to my coaching background, you know, we always see the beginning of the top of the spin of the situation going wrong, because a rope fails, you have to do something you wouldn't be doing, like put someone on the foredeck, and therefore the situation spins. That maintenance can stop all of that happening. But this rope would have told you this was going to happen a while before total failure. The picking of the rope is really, really specific. So if you ever come across a line with this kind of Mohican 90-degree picking, then that's something to instantly look at getting a rigger in to identify where that problem is, because that will only get worse. The other one we see quite a lot of is twist. So twist manifests itself in two different ways. One is a boat handling issue, which can quite often be the genoa sheets. You let the leeward sheet off in the tack, and then the rope twists into a cockle, and the cockle gets stuck in the sheave in the feed, and then you get pinned with the sheet locked into windward. That's kind of a normal ergonomic issue with twist. The other place we see twist is when it's been not induced by a human and a winch, but when it's been induced by a system. So rope, when it's spec'd in a deck layout, the sheaves of the blocks should be 10% bigger than the rope. And that gives the rope the ability to flow through the sheave without generating too much twist. The key to that is that the rope runs straight through the middle and that the block is not twisted. So the sheeting angle is really important. In the ropes you can see in this image, all of these ropes were put in at the same time. The rope on the left appears to be running through the middle of the sheave, but someone's added a Dyneema fob to the bottom of this block. And when that fob is loaded, it twists the block. Because when I inspected it, for the life of me, I couldn't understand where this twist was being generated. Now, the twist in the yellow rope is so severe that the white flecks you can see are actually the core of the rope starting to come through the cover. The cover is polyester, and this would happen to a piece of double braid as well. If you twist it and twist it and twist it, eventually it will just fracture and break, and the cover will come off, and the whole rope will fail. So the alignment of sheets in deck layouts is really important. We see a lot of twist in German main sheet systems, but we see them in masses of cruising boats as well. The two ways it's generated is block size. And with anyone buying blocks, the smaller the block, the lower the cost. So it's always very tempting to come down in block size. And we see that with certain OEMs. Other people who are shopping for aftermarket blocks, obviously there's always a desire to buy less expensive products. So the speccing of blocks is really important. That if you're looking at a deck layout, that the blocks are 10% larger than the rope. Otherwise, it wears the rope, it can generate twist, and twist leads to those failures or those issues with ergonomics. The way that we put twist in is winches, and inevitably it is people hanking rope. Everybody wants their rope to be sat nicely on the winches, nice overlapping hanks, but by putting them in overlapping hanks, we actually build twist into the rope. They want to be left in figure of eights for the rope to naturally fold. So that's what's generating the twist. In terms of winches generating twist, if you look at the image on the left, the small image on the left of the two winches, you can see that even this is a brand new OEM deck layout, and there is already twist in the grey rope on the top of the winch, and that is just what's happening with the sheeting angle coming off the block on the side of the boat, and the very nature of it being twisted on and then stripped from the top of the winch. So if you come across a main sheet system or a fine tune and everything is really well twisted up, then the recommendations is that you get a rigger, you get Andy to come and have a look, and somebody to spec it properly, because it's very simply rope, block sizes, or sheeting angles. And it looks minor, but the ergonomics of it can be quite serious, and it will also damage and wear the rope out. Your rope should last 46,000 miles. The rope on the clipper boats goes all the way around. We do another season of training on it, and then we change the clipper boat rope just before the next race. So rope should last a really long time, but it's about getting all of the touch points and the interactions right, so that product does last and is more sustainable and more cost effective. So the other thing that has quite a big impact on rope is winches and human beings, obviously. You don't see this as much anymore. This is a, excuse me, a molten cover. So this is where a polyester rope has been probably 3 or 4 turns on a large winch and just backed off continuously under load. Normally on the guy of a spinnaker, you would see this if somebody inexperienced has got it in a broach and slowly backed it off. You can generate enough heat around a winch, even a radial winch, to melt the cover of a rope. If you have any of this kind of scarring or anything molten on a rope, it should be condemned straight away. If you use it again, it'll crack, the cover will come off, all sorts of trouble will present itself. And that's normally a crew handling and a training issue. But if you see it after the effect, then the rope really is condemned. The other place you might see significant damage to sheets, either in German systems or in kite sheets or Genoa sheets, is the surface finishing on a winch. So stainless steel winches, the new Selden winches, the Anderson winches, the Harken radials, these all have a finish which is designed for cruising boats, designed for polyester ropes, and you'll get really good performance and interaction with rope in terms of grip, but in terms of lifespan. If you're stepping onto a boat to do an inspection and you see that the rope is almost like someone's run 60 grit sandpaper up and down it, it's excessively hairy in the trimming points, it usually indicates that the rope isn't ideally matched for the winch. It's usually where you see polyester covers being used on performance winches, anything with basically a high grit top to bottom coating on the winch will aggressively abrade polyester. At that point, you really need to move to Technora or one of the Aramid mixed covers to manage that. You do often see it when people get winches regripped. Instantly, they will destroy all the previous set of sheets. So that's where you will see really sort of aggressive abrasion. So if we look at double braid specifically, because that is a degree of the bread and butter of the work, really, the double braid product, it tells you very quickly what's going on. It shows abrasion by fluffing up and hooking. If you fracture the cover in any way, as with the red picture on the left, then you've really got to remember that 50% of your brake load is in that cover. So any damage to the cover, any massive degradation of color, certainly on polyester double braid, is worth paying attention to, because that means the UV has heavily interacted with that cover. And it gives you a point that actually possibly you should replace. The other thing that you might see less often is the core prolapsed from the cover on this blue rope on the right. This is invariably always split rings that haven't been taped up properly. On cruising boats, we tend to see less maintenance of split rings, certainly in the guard wires and in the push pit. So if you have a prolapse core like this, it's always a slightly strange one to look at, because you must wonder how on earth that got out. But if you slide the end of a split ring in and out, it can do a remarkable amount of damage. And that rope is really redundant now. There's nothing you can do with that. That's a replace. The other place you might see ruptured cores or bubbles is on really inexpensive rope, because the cover is not braided as tightly and it's not being pre-stretched and heat set. So that's the other place you might see that. Now, the big takeaway when you're looking at rope in terms of any of the loaded elements, whether they be sheets, halyards, any of the higher load elements, we've been tying knots in rope since we were small, and we've never really seen rope exploding, because polyester ropes have quite a short pitch to them, and they can handle a bowline a figure of eights, a round turn and 2 half hitches, you know, really well. And we're all sailing on big safety factors as well. So, you know, we've never really had big issues with failures. The thing that I'm really keen that people take away is with the move to Dyneema, which we see more and more. Obviously, we're seeing it in the backstay, but we're also starting to see cruising Dyneema as quite a normal thing now. When we're inspecting people's boats, cruising Dyneema is coming more and more. And as the price of Dyneema comes down and the prevalence of the cheaper UHMPE fibers from China comes in, then we will see this product more regularly everywhere. The problem with this fiber is if you tie a knot in it, you're losing 80% of the brake load of the rope, which is a big difference to 50%. So we're really trying to focus a lot of our attention on education and training people and testing to make sure people are aware of this as they move through. We do a lot with the dinghy sailors and the younger folk who are going to be buying cruising boats in 10, 15 years' time. So the way to get around this, and the reason this happens, is the D to D ratio, as in this image. So because Dyneema has a very long lay fiber to it, when you bend it close to 90 degrees, it's really only the fibers around the outside of the rope that are actually carrying any load. The fibers on the very inside are completely compressed. The ones through the middle aren't really being in any way effective, and you're only carrying a certain amount under tension. And Dyneema really doesn't like that. So all we're saying to people is, if you are tying knots in Dyneema, be aware of what you're using. But when you've got cruising Dyneema coming in, people like for like swapping a piece of double braid at 10 mil for a piece of cruising Dyneema at 10 mil. It has the same brake load, but the failure mechanism is completely different. So when they tie a bowline in it, they're ending up with a piece of rope that is much weaker than the double braid that they had in place, unless it's spliced. And that really is the key thing. So a blood knot or any of the other quick trips will significantly reduce that. So if you're walking onto a boat that's 5 years old, you've kind of got to look at a blood knotted halyard within its environmental impacts over the last 5 years, and the fact that it lost 80% of its brake load when you put the blood knot in it. So does that then need looking at? So avoid knotting and really make allowances for reductions in strength. It's really what we're communicating to the cruising community and everybody else. So we have data on all of this on the Marlow website, and all of the significant testing around the results you get by splicing and using those skills versus tying knots. And then it's there really for everyone to make some assumptions about. So that was quite a broad introduction to all of those elements that we're dealing with within rope construction. You know, rope is incredibly robust. If I summarize, you know, we put rope on boats and it laps the globe. With UV and good maintenance, then, you know, you should be looking to have your rope last. You know, it will last 8 to 10 years if it's looked after, like anything else. But it is textile and it suffers when there's a lack of maintenance or damage occurs. It's always the first thing to show, or the human error where it's been incorrectly rigged or rigged around something. So we see the damage majority that way. But rope should last. And if it's in any way damaged, the telltale story is there for somebody to go and investigate. But if damage has happened, the chances are that damage will persist and continue. But per se, rope is extremely well built and should last. Is probably where I'd want to end. Now, I'm sure people have got some questions, and I tried to keep this fairly concise because people have many experiences of rope, and I'm sure people would be keen to ask some questions. So I guess I would hand that back to you, gentlemen.
David, thank you very much indeed. So what I would like to say is I'm not a surveyor, I'm not a technical guy at all, but every day's a school day, and I will never look at another piece of rope again in the same way in my life, I don't think. Quite extraordinary, really. Really interesting. So, guys, any observations or questions or thoughts? Anything you want to know about rope? You've stumped the
You were going to
audience.
go through the various uses of the materials, like polyester, nylon, and, you know, natural fibers which are still used.
Absolutely.
Yeah, okay.
Yes. So that's a very good question. So polyester is probably the workhorse product for double braid and for cruising ropes, and still very much in the covers blended with technical fibers on racing boats, because high tenacity fiber, it's got good UV resistance, and its elongation can be mitigated with pre-stretching and heat setting. So polyester really is a go-to product, certainly for halyards and mooring lines as well. And for mooring lines, when you weigh up mooring lines, nylon versus polyester, polyester elongates 12% to the point of failure. Nylon is towards 30%. So nylon is a fantastic material if you're sitting at anchor. That is by far the most comfortable thing to sit on, and I would recommend. And also the spliceable nature of nylon, certainly in multiplat or octiplat, whichever way you're describing it, means you can get a really secure splice to a piece of chain, and you can end up with your primary safety tool and comfort tool being extremely robust. The downside of nylon is the UV issue. Most people have seen nylon go quite yellow. As soon as nylon starts to go yellow, its brake load starts to dive very, very quickly. So as a mooring product, it's not ideal, because it's like the dyno rod van. It's horizontal to the sun, and I'm so sure you've all seen the dyno rod vans when they used to have an orange bonnet and an orange roof and orange sides. The bonnet and the roof used to be bleached out to white within a year, and the sides were absolutely fine. Nylon laid out on the pontoon and horizontal to the sun in a mooring capacity will very quickly be beaten up by the sun, which is why most people are on a polyester dock line or polyester 3-strand, and we don't see much of the nylon product unless it's got a polyester cover on it within mooring. It is a perfect product for it, but the UV dictates that it's not used as much. So I hope that answers that question. Was there another element to that in terms of fibers? I think the only thing I didn't cover was the aramids. So we used to use a lot of Kevlar and a lot of Vectran in the cores of rope, and PBO also. And now we simply don't do that because of the UV intolerance of Vectran, Kevlar, and the PBO. If you leave, we used to make aramids in the same way that we make 12-strand Dyneema, and you would likely see one of those ropes fail in about 18 months if left in UV. The alarming problem was with them, I don't know if anyone's ever sailed with them, is they would give you absolutely no warning that they were going to let go. And that's why dinghies like the laser band aramids from the cores of ropes way back in the day, because I remember my parents blowing kickers up with, no knowledge it was going to happen. So majority, everybody is on Dyneema now, especially for backstays, all those kind of things. You do occasionally see aramids or PBO backstays from OEMs, and we had I think we had 3 or 4 failures 2 years back on PBO backstays that had a braided cover on them, and they had as little as 900 kilos left in them, and they were 44-foot plus boats. One rig went down, one rig nearly went down. So we got some of it back here. It wasn't our product, but we were keen to understand what was left. And all that was left was 900 kilos, and it was a 10 mil backstay. So anything aramid is definitely worth having a very serious look at when you come across it.
Thank you, David. Any other questions in the room? Yes,
Are there any particular issues with low friction rings?
with
Low friction rings?
low pritted,
Low friction.
oh, low friction rings. Any particular issues with low friction rings?
No, by and large, low friction rings have been a really welcome addition to standing rigging, really, and running rigging. The radius is really good with them. The only place I've seen them be an issue is where they get damaged. A lot of boats use them for in-haulers on Genoas, but then they tend to smash around on the cockpit roof or get abraded on the deck grip, and then they become quite sharp. So that's the only real negative. I think you just need to make sure you've got the biggest diameters you can and that the maintenance of them is good. But no, by and large, they've been a really welcome addition, especially with Dyneema. They sort of fit into that old school rigging with rings and ferrules. Works very well.
Okay, thank you. Any final points before we let David go? No, everybody's very happy, David.
Okay, that's great. I would extend the same offer as Andy in that we're a UK manufacturer. We're all attached to a phone, and if anyone ever has anything they want an opinion in, we have a large technical team. We build, design, and do everything here, and we've been doing it here for 200 years. So if you ever need an opinion, we're always happy to offer it. The best way with rope is to send a photo, and then we can give you an opinion on it, or how it might have happened, and we're very accessible for that. So if you do need any support, or if there's further training that people want to do, or if people would like to come here to the factory as a group, we'd be very welcome to extend that so people can get a better feel of how rope is produced, and how best to look after it and understand the manufacturing. So please do get in touch. The number on the website will get you straight to either Rob or myself quite quickly if you ask for us by name.
That's kind of you, David. Thank you. And we'll make sure to include your contact details as well when we write back to everybody. So could I ask you to stop your share, please? Yes. Thank you very much. And the round of applause.
Most kind. Thank you.
I need to stop my recording here. Where's my recording gone?
Very good.
There we go.